Thank you for having me. I'm really honored to be here, and especially really honored to be introducing Gerrit, as AllSeen so quickly sold out all of the seats for this event. I wanted to start by setting a little bit of context, highlighting a few examples, not only of why security matters so much for the Internet of Things, but how it often differs from the traditional security needs of traditional information technology, traditional IT. I mean, in IoT, it's not just about the baby monitor that got hacked, where the stranger was screaming through the baby monitor to wake the baby. And it's not just about the security cameras and other cameras around the home that have been hacked, spying on couples while they're trying to spend some time home alone together. I mean, it's not just about the privacy of our homes and the privacy of the data about our lives at home and trying to keep that data away from not leaked to nosy neighbors or untrusted cloud services. But when we think about those devices that are near each other, that are in proximity to each other, around the home, any principles of proximal security, for those devices around the home probably aren't that different than the principles of proximal security that would be needed for devices around a factory or a logistics center or an office or the inside of an airplane or the inside of a car. So as an example, if you think about a factory, it turns out that the robots on a factory floor actually do need to have wireless connections for their components to talk to each other. But those wireless components shouldn't be talking to the cell phone of a random employee or worse, a random contractor, walking through that factory. And those wireless devices that, those robots that are making cars that our lives depend on should not only not be talking to random strangers going by, but shouldn't be enabling eavesdropping from the parking lot, even if they have a really good antenna. I mean, what's happening in the factory needs to stay in the factory. It's private. And perhaps more importantly, when we think about the cars and the airplanes that now have tons of embedded computing technology in them, that our lives depend on, that are now connected embedded technologies that our lives depend on, security for IoT really, really, really matters. And it doesn't just matter a lot more than a lot of traditional information technology contexts. It's also very different than the security needs that are needed for a lot of traditional IT contexts. And so when I say different, I'm not just talking about the difference between an embedded microcontroller that's an 8-bit microcontroller with 32K of flash running at 8 megahertz versus these smartphones that we all carry that run at gigahertz speeds with gigabytes of RAM. It's not just that orders of magnitude disparity of difference in capabilities, but those smartphones and tablets and laptops and desktops and servers. In an enterprise, they all have teams of enterprise administrators, making sure they all talk seamlessly to each other, connect to each other, and not only connect, but do it safely and securely. Our homes don't have teams of administrators. Nobody wants to spend their life being the administrator for the thermostat, or the light bulb, or the motion detector, or the door lock, or anything else. These things from all these different manufacturers, because consumers will buy different technologies for different roles from different makers, they need to all work together seamlessly right out of the box and do it not only seamlessly, but also safely and securely. And that's why I'm really glad to see a number of industry efforts, both standards efforts and great open source efforts like the AllSeen AllJoyn project, that are not only speccing the standards, but writing the code for all of this technology to work together, not only seamlessly, but also safely and securely, right out of the box. That's why I'm really glad that Gerrit is here today to give us an update on the philosophy and the principles behind security in AllSeen, and an update on where security is in AllSeen 1.0, and a preview of where it's going with Security 2.0. With that, without any further ado, Gerrit Ruelens.
So, hi. Yeah, go to the next slide. So, the security for AllSeen. Can we go to the next slide? Okay. So, what are we trying to achieve here today? So, we're building an Internet of Things where devices and applications seamlessly are working together in a secure and privacy-conscious manner, where the end user is in control. So what does it mean? We already said seamlessly working together. So we have devices, applications from all different vendors teaming up together, making sure we get a nice experience. So we need to focus on standardization, knowing that if you have a TV remote control, it can control all TVs. But also for security, it's important that the extra means of security we introduce are not standing in the way of seamlessly cooperating together. As Brian already mentioned, we have to be secure, we have to protect our devices. Meaning that if I have my oven, I don't want it to be turned on for a long time, it could catch caught fire. But also, in the other direction, if I consume services from other applications, like a smoke detector, I want to make sure that if I get an alarm, it's really from my smoke detector and not the one from my neighbor. So there is a real reason and a real focus on getting things secured, and not only for making sure that our services don't get abused or we get false alarms, but also to keep our privacy safe. We have a lot of important data in our home. We have a lot of sensitive things we don't want to share with the whole world. So we have to make sure that security is there and put in place so that also our privacy is protected as it should. And finally, we put the end user in control because he will go to the shops, buy devices, go to the Android store or download applications, and he will put the ecosystem together in his home. So we should allow him to do so. Next slide. So how do we build up our security? We have three pillars. So first of all, authentication. What happens sometimes to me is when I leave my home and I drive away preoccupied and thinking, did I lock my door? So it would be nice if we could have an application which looks at the door and see whether it's locked indeed. But when I do so, when I check my door, I want to make sure that it's my door I'm checking. I need to be able to authenticate that it's really my door. So the door, like a physical passport, needs to prove it's indeed my door. From the other perspective, if I want to unlock my door, not just anyone should unlock my door, so we add some forms of authorization rules. So like the traffic light, you either get a red or a green sign to continue. I have to prove that I am indeed entitled to open the door. Just like the physical key that I have to unlock my door, we'll be handing out digital keys to unlock the door. And finally, we have encryption to make sure that we can protect our data, that people cannot eavesdrop, and all the sensitive information remains trusted for us. So when we started off with the architecture of the Alliance, we made sure that security is incorporated from day one. We don't want to put security on top of it, because then it will be very hard to make a really secure system. From day one on, we made choices which make it easy to incorporate security. So we started off with the peer-to-peer communication, allowing us to encrypt the data communication from end to end, so no one can eavesdrop. It also provides extra robustness. If some node is falling apart, we can continue. There is no single point of failure. We do have the router nodes in there, but if one router node goes away, we can replace it by another one. There is no single point of failure. The end-to-end encryption also makes sure that even the router nodes will have to pass along the messages. They can't read the content. So the security is there. There is a deliberate choice not to include the cloud in the architecture. Again, privacy. We don't have to send information towards the cloud, so we can keep our data local. There is less risk of losing or privacy leaks. But also, we want to enable really limited devices. And for those devices to cooperate with the cloud service, that's tough. So with a more proximal approach, we're able to make sure that also those small limited resource devices can join the AllSeen network. Like we said, cloud is not that bad. It's not bad at all. There are many very valuable services in the cloud available. So we have a component called the gateway agent, which allows you to bridge those cloud services towards your home network. The gateway there will make sure that it's happening in a secure and privacy-safe way. So also those small embedded devices can indirectly interact with the gateway agent. LAN security is not enough. So we're putting all those devices together. We put them in our home, and we hope that it's safe. But in the end, our LAN security is not what we think of. We could have attackers trying to get access to our Wi-Fi network. Even with the latest Wi-Fi security, that's possible. They could attack our internet gateway and try to get access via that gateway to our network. But even those are, well, protected good enough. The real danger is with our smartphones. We install applications, and basically any stupid flashlight application can try to attack our home network. So we've seen that before, that there were some rogue applications which provide flashlight functionality for your smartphone, but then on Android they asked permission to get your SMSs, to get your contacts, to get network address, and they just put all that information towards the cloud. So any application on our smartphone which is in our home network will have access to our network. So it could try to interact with our devices which are talking AllJoyn. So it's key to make sure that the setup is robust enough to protect ourselves, to keep our data private, even though we have applications listening and trying to steal our data. Recent studies from HP showed that from the currently available devices, 70% of IoT devices has vulnerabilities, and there's a possibility to attack those. So it's really key, and it's not that easy to make those devices secure. So that's why there is a strong focus in security in AllJoyn. So if, as an application developer, you use a framework, you can be sure that you can build an application which is secure and is protected against such risks in your home. So what use cases do we try to address? If you look at the living room of tomorrow, we see a lot of interesting applications. We can start off with the lights. You can use your smartphone to control the lights. All the members of the family should get access to those lights. But there are far more interesting use cases when little Kevin is sitting in the TV corner watching TV. It would be nice if the TV is able to control the lights, set the lights to a nice viewing scene, or even go further, that the TV just uses the lights to get some more experience. If you have your game console and you're playing a game, that the game controls the lights to get a more dramatic impact than just having the light set equal. Little Lisa, she likes to bake cookies. That's one of the things she can't do alone. We have to restrict access to the oven to the kids. So if she wants to cook, she has to help. She has to ask her mom or dad to get some help. On the other hand, the oven offers some usable nice features. Suppose that if you have your cooking application on your tablet and you want to make a roast, the tablet could program the oven to set the temperature right, to change during the cooking, set the temperature right, and make sure that your cooking experience is far more easy. And finally, if you look at the TV, there are some interfaces there, a very basic one to control the TV. But on the other hand, there are more advanced features like parental control, which needs to be configured. So if Kevin is watching TV, he should be able to control the TV, he should be able to switch channels. But when it comes down to configuring the parental control, that's something he should not be able to do. So he should be authorized to control the TV, but he should not be authorized to set up the parental control. And again, from the parents' point of view, it would be nice if they could say, well, Kevin is allowed to watch TV for 2 hours, but some more use cases could cover that it's not just the single TV, it should be all TVs, it should be the game consoles. So if they could all cooperate together, they could have a more home spread parental control, so allowing only Kevin to watch 2 hours on any TV regardless. From that use case, we have a definite need of identities. So if someone tries to control the TV needs to be aware of whether it's Kevin, whether it's mom or dad. And it doesn't matter which device Kevin is using for that. So if he uses his own tablet or his own smartphone for the TV, it should still be Kevin. So from security perspective, we need authentication. We need to be able to authenticate which application tries to access another peer. We need to identify which users are doing that, so it's not the same as the application. So a user could operate more than one device, so we have a distinction between the real physical user and the identity of the device or the application doing it. We need fine-grained access control, so not just on and off authentication, but we need to be able to specify you can do this on a device, but not this. Okay, next slide. So what's the current status? At this moment, we can offer a secure solution. Can we offer all of our use cases? We're not quite there yet. For authentication perspective, the framework offers numerous ways of authenticate, and it's up to the application to incorporate one of those mechanisms. Once you get authenticated, you get full control of a resource, so we don't have fine-grained policy at this moment. And we have full end-to-end encryption, so we can secure or guarantee privacy. Moving forward to AllJoyn Security 2.0, we try to focus on getting all the use cases covered. So authentication will be handled completely by the framework, so it becomes transparent for end users which form of authentication is used. So if we have multiple applications joined together, they will use the same authentication and they will cooperate seamlessly together, which is not yet possible with the 1.0. We will offer full fine-grained access control, so the use case where the TV has to differentiate between the controlling or the configuration of the parental control. We can provide that one, and again, encryption is still there. On top of that, we'll provide the strong identity management, so it would be able for an application or a device to determine who is operating it or if on whose behalf the request is made. And also, we are adding a feature to protect our application or the end user from his applications. If he downloads an application on his smartphone and he will give it access to the AllJoyn network, it's very hard for an end user to determine what will it do on the network. Can I trust it to do that on my AllJoyn network? If you install an app, a remote control app, you might say, okay, it's fine to control the TV, but I would not want that single application to open my front door. So we're adding a mechanism there so we can say that when a user installs and he gives an application access to his AllJoyn network, he will be able to see what that application wants to do on the network, and he will be able to restrict that application to only do such things. So I would like to thank you for your attention. And then later this afternoon, we'll have the introduction session where we will go more in detail, in technical details on how we address the security. So I hope you can join, or also in the core, we'll have a discussion there a bit more in deeper detail.